wanted to give you a quick example of how to use the definition of a logarithm to solve exponential or logarithmic equations. Now, these are simple equations that only need the definition of a logarithm. Here's the definition of a logarithm. If y equals b to the x, then log base b of y is x. And the key is we can go back and forth between these two. All right, so if you have one form and you need to solve it, switch it to the other form. So watch how this works. Okay, so we have an exponential equation here on this first one. So first thing we've got to do is we got to get the exponential by itself. We get that 4 out of there. So 3x minus 1 equals 6. Now, this is in exponential form. This is in this form. So the x is in the exponent, so we're going to change it to the logarithm. We're going to take this base and swing it around, and we're going to rewrite this as log base 2. The base of the exponent is the base of the logarithm, and that equals 3x minus 1. Now, log base 2 of 6 is a decimal number. We'll figure that out in a minute. Right now, let's keep it exact. All right, so let's add 1 to both sides. Just leave that log base 2 of 6 alone. And then we have 3x equals log base 2 of 6. It's kind of like the square root of 6. It's not really, but in the same way that the square root is a irrational number. And then we're going to divide this whole thing by 3. And I'm running out of room. So we divide this by 3. Okay. And we end up with something like this. We're going to have x equals log base 2 of 6 plus 1 over 3. Kind of ugly, but that would be the exact answer. All right. Well, how do we solve that? Well, we can take the log base 2 of 6 and we can plug that into a calculator. And we got to use a change of base formula. So log base 2 of 6 is the same as the natural log of 6 over the natural log of 2. Okay, that's not 6 divided by 2. Or you can use the common log, which is log base 10 of 6 over log base 2. You'll get the same answer for either. Punching these into our calculator, we get about 2.58496. Okay, now if we take that number and we add 1 to it and divide by 3, and be careful with your order of operations there. If you can use your second key or your answer key, that's great. And that gives us an approximate answer of 1.19 when we take this number, add 1, divide by 3, and round off a little bit there. 2 decimal places is good. So, all right, so that was an exponential equation where x was in the exponent, and we changed it to a logarithm. Okay, so the key is, again, we started with exponential here. Let me change that. Let's see. Started with an exponential equation, and right here we changed it to a logarithm. Okay. Well, now we're going to reverse that. So here we have an equation that is a logarithm, and so let's solve that up. We got to get the logarithm all by itself. This is log base 3 of x plus 1. First thing I got to do, if we got anything out here, we got to get rid of that. Got to move it to the other side. So we have log base 3 of x plus 1 equals 4. Now this is in a logarithmic equation. This is in this form. So we're going to change it into exponential. So notice this b base from this equation to this equation. The base is just going to swing around, and it's going to be the base of an exponent now. The base of the log, b, becomes the base of the log, or I'm sorry, base of the exponent over here. So let's do that. Let's take this base, swing that base around, and we can rewrite this as 3 to the 4th equals x plus 1. Now this exponential, this is easy to figure out. This is just 3 times 3 times 3 times 3, and that is 81. And so x plus 1 equals 81. Subtract 1 from both sides, and x is 80, and we are done. You should always check this, plug it in. Is log base 3 of 81 equal to 4? And if you use your calculator for change of base, log base 3 of 81, this is just saying is 3 to the 4th power 81, and it is. And actually, we should probably plug it into the beginning up here. Okay, this does come out to be 4 minus 3, which is 1. And so, yes, this checks out. All right, you can do the change of base log 81 over log of 3 to find out that, yes, that is 4. All right, so there you go. Now, that doesn't use fancy properties. If you go look at other YouTube videos, you're going to see fancy properties. But once again, we're taking our original equation, which was a logarithm, and we're changing it into an exponential equation. And once you change it to an exponential equation, you can solve it. Starts as a log, change it to an exponential. If it starts exponential, change it to a logarithm. All right, that's how that works.